We need to review some of the basic combining like terms, things that will help us with this chapter. We're skipping chapter 1 in the book. We're going to do chapter 2, 3, 4, and then go back to 1 because in my mind they did them out of order. So we have talked about order of operations in the past. So if I had 3 times 2 times 4 plus 1 minus 6, which of those do I do first? I have 5 different operations or 4 different operations. Which one is first? We have to look in the inside and we're going to do the multiply. So that's first, second. Then we go outside and multiplication comes before subtraction. And if you don't perform the operations in that order, you're going to end up with the wrong number. So we would say 8 plus 1 is 9. And then 3 times 9 minus 6. 3 times 9 is 27. Minus 6 is going to be 21. And I think you guys are really good at that, at those. Okay. What I notice with kids in this class is when you have to combine like terms, sometimes you have a hard time remembering, does that make 2x or does that make x squared? Know what I mean? So if I had 3 plus 2, that's sort of like taking 3 of something and adding 2 of something, and now I have 5 of something. Pretty simple, right? Well, the same is true when I start adding variables. So if I had x plus x, that just means I have 2, well, hold on, let me do that a different way. So I have an x, and I'm going to add an x, and the only result that can come out of that is 2 x's. Right? Now, what if I did x times x? So 3 times 2. So that would be a 3 and a 2. But now I'm multiplying them together. So I have to build a box that has 3 on one side and 2 on the other. So I build a box that has 3 on one side and 2 on the other, and I end up with 6. And I sort of have altered what I'm looking at. I used to be looking at a single row of something, and now I have a 2-dimensional shape that has one of those numbers as its column and one of those numbers as its row. Okay. Well, how would you do x times x? Yeah, I have a kind of an unknown, right? I don't know how big that is. It's just x. Yeah, and it could be any number you plug in. And then on the other one, I have the same thing. And what kind of result comes out of that? X squared. So basically, on this side, I rotated that and stuck it in that orientation, and then I filled in the rest. So I need to rotate this up, and that's x, and then I have to fill in the rest. Well, what shape is that? It's a square. So when you're adding things together, all you do is count the total number that you have. When you're multiplying, you create rectangles or squares. So x times x is going to be x squared. And that's different from 2x. So addition, we just add things. We count how many there are. Multiplication, we create squares. What if I did x to the third? What would I create? A cube. So I would kind of have, this would be length x, and then this would be length x, which builds a square, and then this would be length x, and we end up with a cube. Okay? So you have to understand the difference between addition and multiplication. Okay? Another way to look at it is if I have x plus, well, let's do it this way. So let's solve 2x plus 4x. So is that going to be 6x or 8x squared? Well, we have to remember what addition does. Addition just groups everything into a big whole. So x plus x, x plus x plus x plus x. So there are my 2x's. Here are my 6x's, or my 4x's. If I count them all up, I end up with 6x. Okay. What about 2x times 4x? Now it's 8x squared. Why? So I have x plus x, that's my 2x, times x plus x plus x plus x, right? So I have a bunch of 2 there, and I have a bunch of 4 there, and 2 times 4 is 8, but because it's multiplication, I'm building a rectangle, right? And I end up with 8x squared. Was that a question, or were you just shaking your locks? That's sadly your voice won't be on the recording, only mine. So sometimes if you're gone, I'll leave you a message. Who are we missing today? I didn't take roll. Daisy and Trace, if you watch the video, hi, we miss you. Okay, what if I did 3x plus 4y? What would that be? So I have 3 x's, and then I have 4 y's. And when I put them together, what do I have? 3x plus 4y. How come? So here I have 3 apples and 4 oranges. How many oranges do I have? Or apples? How many or apples do I have? None. They don't exist. I still have 3x plus 4y. Okay. What if I wanted 3x times 4y? Well, it's multiplication now. So 3 times 4 is going to be 12 xy. Does that make sense? So you cannot add terms together unless they are like terms. But you can multiply terms together. That's totally fine. All right, let me... So open to the first section in chapter 2. Uh, 66. Look at number 6. The degree of the monomial. The degree is the biggest exponent. Now, that's like number 18. See how there's a first power, third power, and fourth power? You always look at the biggest one. That's the degree. And if a term has more than one exponent in it, then you add them together. So like number 10, we have m squared and n to the fourth. We would add those together to be 6. So number 6 would be 4. Number 12 would be 4 plus 1 plus 6, which is 11. Okay. For number 14, it says write the polynomial in standard form, which means you put it in order from biggest exponent to smallest. So for 14, we're going to write negative w to the 12th plus 4w to the 11th. That is called descending order, biggest exponent to smallest. And it says identify the degree. So this would be degree 12. And it wants to know what is the sign, or not the sign, sorry. It wants to know the leading coefficient, which is this number here in front of the first one. So the leading coefficient is -1. And then classify the polynomial by its number of terms. We have monomial, which is 1 term, binomial is 2 terms, trinomial is 3 terms, and then quadrinomial, and after that we just kind of say 5 terms or 11 terms or something like that. So this would be a binomial of degree 12 with a leading coefficient of -1. Okay. What about 16? What order would I write 16 in? Good. -4d to the third minus, oh, hold on. I did it wrong. Plus 8d minus 2. We're looking at the exponent on the variable. Yeah. So d to the third, d to the first. And this is kind of like saying d to the 0. We don't bother writing it. But that's what descending order means. And then this has degree equal to 3. And the leading coefficient is -4. That make sense? The reason we want to know this is that number tells us a lot about the shape of the graph. And this number also tells us a lot about the shape of the graph. The other numbers come into play, but those two give us a really good starting point of what's going on in that function. Okay. So then look at 23 through 38. You're going to add polynomials together, and then you're going to subtract polynomials. So adding polynomials is pretty simple. You just combine like terms. For instance, number 24 says -8x minus 12 plus 9x plus 4. And we just look. X, what is -8x and 9x? That would be 1x. And -12 plus 4 is -8. That's the simplified version. When you subtract, it gets a little bit more complicated. How do we subtract polynomials? Anybody remember? Well, I have to make sure that everything on that second, in that second parentheses, gets hit by the negative. So it's kind of like, it's like having a -1 right here. Well, the first parenthesis is in front of the subtraction. So I'm going to multiply both of these by -1. So -7x plus 3. Now I can add the two parentheses together. So the way I look at it is you just change the signs on the right side and then change that to a plus. So now 4x minus 7x. So that's -3x. And then -6 plus 3 is -3. Okay. So your assignment today, don't know what I did with it. Here it is. Your assignment is 5 through 45 odd and number 51. So you have a couple of story problems in there. And then, yeah, just a few. Yeah, you're going to do all of the odd problems from 5 to 45, and then you'll also do number 51. So you'll do 5, 7, 9, all the way up to 45. And I believe I haven't been in this book. I didn't teach this class last year, but I believe that there are answers to the odds in the back. Yeah. Oh, yeah, certainly you can work together. The answers are in the back. Make sure you show your work. If you don't show your work, you don't get credit. But I will do my best to make sure that you have the answers so you know if you're doing things correctly. All right? Get to work.